In this video, I want to show you how to solve a quadratic equation by completing the square. Here is the first example to illustrate the technique. So the first thing you need to know actually is to determine the term that will complete the square for the first two terms. Okay, so we're going to set it up this way. We're going to say n squared minus 10n plus some number that will complete the square. And then we're going to subtract that same number that will complete the square. And then add, like we have, plus 21 equals 0. So our job is to find that number that will complete the square for when you have this setup. So let's go ahead and look at the middle term. So negative 10, we'll take a half of that, we'll get negative 5, and then we'll square negative 5, and then we'll get 25. That is the term. That is the term that will complete it, 25. So if you add something to this side, you must take it away from that same side. All right, so now we're going to try to finish it off by actually factoring this like a square, okay? Like a perfect square. If you are in class, this is easy. Going by the box method that we used, that you need to divide this 10n into 5n, and then it's actually negative 5n, and this is n squared. This must be n minus 5, and must be n minus 5. This is where the 25 is coming from, and this n minus 5 times n minus 5 is n minus 5 squared, okay? And then we can subtract or add these terms together. Negative 25 plus 21 is negative 4 equals 0. And now that we have completed the square, next thing is to try to get n by itself. So we add 4 to both sides, and then we will get n minus 5 squared equals 4. So now we're ready to take square root of both sides. So we're going to take the square root of both sides, like that. Square root. I need to modify this a little bit. So we have to use plus minus because two answers are always possible. So now the square and the square root are inverses. They're going to cancel. So we're going to have n minus 5 equals plus minus 2. And then you add 5 to both sides. So n equals 5 plus minus 2. So if you do the first side is n equals 5 plus 2, you get 7, or 5 minus 2, you get 3. So really, that's how you use completing the square to solve an equation, okay? So now, that's the easy problem. What if I gave you another kind of problem like this one, number 21, from the homework packet? Let's see, number 21. So if you have this, there is a number on both sides. So the first thing to do is, we can leave the number right there so we don't need to bother. Or you can just actually subtract it from both sides, doesn't matter. So since you are used to having 0 on the right side, I'm just going to subtract it from both sides and leave it as 0 on both sides. So now we're going to complete the square like we did before. So r squared plus 10r, plus something, and then minus something, plus 13 equals 0. So the thing that we're going to subtract is 25. Add 25 and subtract 25. So we're going to do both. And then this will be r plus 5. and then that will be a positive, so, squared, and then this will be 25 minus 25 minus 13 is 12, negative 12. So negative 12 will be here, and now actually it's minus 12 equals 0, and then we can add 12 to both sides. R plus 5 squared equals 12, and then we can take square root of both sides like this. R plus 5 squared equals plus minus the square root of 12. Now we can simplify the square root of 12 as the square root of 4 minus square root of 3. So now we're going to have R plus 5, no more square, equals plus minus 2. This is 2 root 3, and then R equals negative 5 plus minus 2 root 3. So unlike the first example in which you can actually take the square root and get an integer, this is an irrational number. We're going to leave it just like that. So our final answer will look like this: negative 5 plus 2 root 3, or negative 5 minus 2 root 3. Okay, so we go to one more, I think, number 25. Here is another one. 25. Okay, it's another one. So in this case, you're looking at the first two terms here and try to complete the square for them. So it will be x squared minus 6s plus something. All right, and then minus the same thing plus 21 equals negative 4. And now a half of negative 6 is negative 3, and negative 3 squared is 9. So we're going to complete the square with 9 and 9. And now we can have x minus 3. If you look at the, if you factor this using the box method, you'll find that. And then plus, so 21 minus 9 is 12. So plus 12 equals negative 4. And then subtract 12 from both sides. So you will get x minus 3 squared equals negative 16. And then we can take square root of both sides like so. And then equals plus minus the square root of negative 16. So now we're going to take the square root of negative 16. From previous concepts or classes, you know that this is going to be plus minus 4i, and then this is going to be x minus 3 here. And now we're ready to add 3 to both sides. So add 3 to both sides like that, and then you're going to get x equals 3 plus minus 4i. This is a case in which you end up with a complex number because you're taking the square root of a negative number. So this is a complex number, and then you can separate it into two, like 3 plus 4i or 3 minus 4i. Okay, so I showed you the one with rational, irrational, complex. Now I'll show you the last one with a fraction, number 35. This is going to be one with a fraction. Let's see. Okay. So let's try to do this. We're going to have v squared minus 7v plus something. All right. And then minus the same thing plus 14 equals negative 5. Now, we can do negative 7 divided by 2, which is negative 7 divided by 2. And then when you square that, you get 49 over 4. So we're actually going to add 49 over 4 to both sides. 49 over 4. So, and then we can write the other side, this side like this with, 1 second. We can write this side like this. V minus 7 over 2 square. You know, we're always taking the half of this, okay? That's a factorization of that in the parentheses. And then we're going to try to add this together. Let's try to do it by the side. Negative 49 over 4 plus 14 over 1. If I multiply both sides by 4 to get the same denominator, I will get negative 49 over 4. And 14 times 4, this is 16, and this is 56. So that will be plus 56 over 4. Now, if you subtract that 49 from there, you will get 56 minus 49. That's a 16. That's a 7 right there. Okay, and this is gone, so 7. So this all will be 7 over 4. So plus 7 over 4 equals negative 5. And now we can actually move it to the other side. V minus 7 over 2 squared equals negative 5 minus 7 over 4. All right, so we're going to add that together. Let's erase here and add them together. So here we have negative 5 over 1, 7 over 4, multiplied by 4, multiplied by 4. So negative 20 over 4 minus 7 over 4. So you're going to get negative 27 over 4. Okay, so now we're going to have the right side as negative 27 over 4. Okay, this is pretty interesting what it's turning out to be. And now we can actually take the square root of both sides. So let's take the square root of both sides as so. And use plus minus that. Okay, now we're going to have to do the right side in two parts. So we're going to do like this. Square root of negative 27 over the square root of 4. The top part is 3i root 3 and the bottom is 2. If you need help with that, go and look at previous videos, okay? So now we're going to have v minus 7 over 2 equals plus minus 3i root 3 over 2. Now we can get that fraction to the right side. So v equals 7 over 2, yeah, adding to both sides. So plus minus 3i root 3 over 2. So which you can separate into 2 as 7 over 2 plus 3i root 2 over 2, or 7 over 2 minus 3i root 3 over 2. So now we see all the possible scenarios where you have, rational number, irrational number, complex number, and then this is complex number with a radical. So hopefully this helps.